Hello everyone. Myself, I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss about the topic of authentication requirements, authentication functions and MAC. MAC it is nothing but a message authentication codes. Coming to the overview of the topics, firstly we need to discuss about what is meant by authentication requirement and what are those methods, and what is meant by authentication functions and what are those types, and what is MAC and the way how it is going to be working. So coming to the first slide of the message authentication requirements. So firstly we need to know what is message authentication requirement and what is the useful of the authentication purposes on the message process. So firstly, the data is prone to various attacks, means such as man in the middle attacks is a main responsible of the message authentication requirement because it is acts between the client and server mode. So one of these attacks includes message authentication process. So the user does not have any information about the origin of the message, means wherever the information doesn't have any of the information. So whatever the message is going to send by the sender, there doesn't have any particular information about of the starting of the message. So this message authentication can also be achieved by using cryptographic methods and also by using the making of keys. So the basic key is nothing but a here secret key. So that is the main purpose of the message authentication requirement. So coming to the authentication requirements of different types or different methods, what it is. So coming to the authentication requirements, there are relevation process, analysis of traffic, deception and modification in the content, and modifications of the sequence and modifications of the timings, and source refusal and destination refusal process. So coming to the first one, relevation. Relevation is nothing but the releasing of the content of the message that is doesn't have an appropriate cryptographic key. It is nothing but it doesn't have any particular of the key process, that is called as relevation. The next one is analysis of traffic. That is nothing but a duration of connection between the frequency or any different parties, that is going to be called as an analysis of traffic, because the pattern of the traffic it also occurs in the networking process. The next one is deception. Deception is nothing but a fraudulent source. Any hacker or any third party services, that is called as an fraudulent source, which is nothing through the into communication network. So basically it works on the communication process that will accept on the only the deception process. So it is led to mistrust between the parties communicating and also lost the particular information or any other important data. The next one is modification in the content. So basically modification is nothing but whatever the message is going to between the sender and the receiver, it is obviously changing the content of a message, means it automatically changes the whole of the content of the message purposes. So it includes basically inserting any new information or deleting or changing. So what is the main purpose of the modification is nothing but either they are going to be insert or delete or any changing of the existing one of the processes. The main purpose of the modification is nothing but between the sender and the receiver, or the third party is nothing but a hacker. The hacker can change the information, he can delete the information or he can change the information. That is called as a modification in the content process. The next one is modification in the sequence. How the sequence is going to be. So it basically includes the insertion and deletion and reordering of messages. So again it reordering, it also insert and it also delete of the messages. And next one is the modification of the timings. So how they are going to be in the time format. So it includes basically replay and delay of the messages. So what is the between the different parties? The different parties is nothing but a sender and the receiver. So like this way the session tracking is also maybe disrupted. So the basically timings will be happened in the replay and the delay of the messages between the sender and the receiver. So it may also track the information. Next one is source refusal part. So source refusal part is nothing but it denies basically of the originator of the message. The next one is destination refusal process. How it is going to be refused? Whenever the receiver of the message denies the reception process. So basically it starts of the receiver of the message, not as a sender. It only receives. That is the true, sender is the false agreement. That is the process of the refusal process. So here we can see an example of authentication. So how the authentication process is going to be encrypt, or it can be decrypt by using a particular data or any other information. So whatever we are using here, see one of the example, it is nothing but a secret key. So here having the data is going to be happen between A and the information of the receiver B, C and D of the 3 receiver process. These 3 receiver process where it is getting the information from the A. A is nothing but a sender process, and this 3 process belongs to the receiver. So already here sender is there and also the receiver is also there. So here the sender is going to be send some of the data to the receiver. So receiver of any of the B or C or D. Of these 3, any are going to be receive the message. So A is sending a particular data. So by using the sending the data, it is going to be encrypt the original format. So the decryption is nothing but a here ciphertext. Encryption is nothing but a plain text. So encrypt by using the encryption process, it is automatically, while receiving the data, the ciphertext is going to be decrypt the message. So that's why here using the encryption process of A's secret key and A's public key. Secret key and also they are using for the decryption process public key. Public key means they can see any of the outside of the person or inside of the person. Any people can see the information of the whole data. So here for the using of encryption process, they are going to be using the secret key. So secret key is basically using for the authentication purposes. The next one is message authentication functions. What is the main functionalities of the message authentication functions? Here we are going to be seeing. So it is basically consists of 2 functionality levels. So there is the functionality levels of lower level and also the higher level process. So in the lower level process, what is going to happen? So it is a need for the function that produce an authenticator. So authenticator basically in the lower level, it will be mainly further helps in the main authentication of a message. So only it is the authentication is nothing but a only it is responsible for the only authentication people only, not outside of the people. The next one is higher level. So basically in the higher level, it is in the lower level function is used in order to help receivers verify the authenticity of the messages. Means nothing but a any of the in order to receive and also the verify of the process. That is called as an higher level. We having 2 functionality levels. One is lower level and second one is higher level. These are the 2 types of message authentication functions. Next one is the 2 types of authentication, how it is going to be divided and what are the ways that can be done in the authentication functions. The first one is message encryption process. How the encrypting message. So while sending data over the internet or any other communication, there is always a risk of MTM attack. It is nothing but a man in the middle attack. So man in the middle attack, it is the basically conversation between the sender and the receiver, means client and server. So always they are going to try the hack the message. That is the main purpose. So in message encryption, the data is first converted to a ciphertext and then they can be sent. Means firstly by using the only first converted to the ciphertext means in the process is very easy. Then after the process, the message is fully sent to the receiver. It cannot be get back to the again sender process. That's why the data is first converted to a ciphertext process. Means not as the original of an plain text. So it can be done in basically 2 ways. The 2 ways is nothing but a first one is symmetric encryption process and the next one is public key encryption process. So coming to the symmetric encryption process. So basically we are having a send to message from M to source of P to the destination. Then after by using the secret key. By every process, we are going to see the same of the message because we are going to take the example of the encryption process. So, a secret key K that both P and Q what is going to be shared. Then after with this K, no other person can get the plain text from the ciphertext. So, this maintain a confidentiality level. And also P has sent the message. So, let us see an example of this process. Here the source P, it is nothing but a sender. Destination of Q, it is nothing but a receiver. Then what is the sender and the receiver is going to be seen? Here M is there and also encryption is there and K is nothing but a key is also there and decryption process, again secret key is there. Here nothing but a destination and it is nothing but a source. So basically here E of encrypted of K comma M. So basically here we have seen the M of the message. Message is nothing but whatever the information is going to send of the particular message that is sent to be the from source to destination of Q. From source means sender of to destination of Q. So that what here message is going to be encrypted format by using an secret key, and after that here we are going to encrypt off by using the key comma message. Then after the key comma message, automatically it going to be converted as an decryption process and the message is sent to the receiver by using the secret key. Without the secret key, we cannot send the information. Otherwise, the hacker will be attack of the any of the messages. The next one is public key encryption process. In this public key encryption process, it is not much as advanced as symmetric encryption process, but it provides a confidentiality. So, only it provides an confidentiality purposes, not an authentication process. So, to provide the both confidentiality and authentication, so it basically it requires the private key is required. So, public key is nothing but a both inside and outside of the persons. The private key is nothing but a only the owners can access the data. That is what they are saying the private key is be used in the public key encryption process. This is the message authentication functions. The next one is message authentication code. How they are going to be work in the code of the authentication process by using the sender and the receiver of the messages. The next one is message authentication code. So see here, the message authentication code is nothing but a security code by using any of the user computer doesn't know any type of access, any accounts or any portal, because by using any accounts or a portal, the computer doesn't have an in order process. So basically it is a one-off type of security code. So it provides the security of message authentication code. So this code mainly helps in maintaining information integrity process. So, and also it confirms the authenticity of the messages also. So basically it confirms helps in maintaining of information integrity process and also confirm the authenticity of a message. So here in MAC process, both the sender and the receiver will share the same key, because only for the fixed size output of the cryptographic hash functions we use the only of the same key will be seen in the message authentication codes. So in the message authentication codes, we are having two types of codes that are HMAC and CMAC also. In the next video, we can see HMAC and CMAC. So these are the two types of the, basically we are going to see in the message authentication codes also. So these both message authentication codes, how they are going to be hashed and how they are going to be cryptographic format and how they are going to be parallelized format also. There is nothing but a PMAC is also there. So there are some of the types of the message authentication codes we can see in the next video. So it also confirms the authenticity of the messages. So by using the authenticity of the messages, the sender and the receiver will also see the same shared key. So that's why they are using the generates of fixed size output. The fixed size output is known as cryptographic checksum or message authentication code. By using the sender and the receiver will share the same key, it is nothing but called as an message authentication code or cryptographic checksums. So basically it appends to the original message. So what is having the original message. It depends on the original message only. So on the receiver side, the receiver also generates the code and compare it with what they are having or received the originality of the messages. So on the receiver side, they are going to be check the information whether the sender is sent the original message or not. That is the receiver's main responsibility of the message authentication code. They are having some of the components. One is message. While we are sending the information, we need to have an message format. The next one is secret key and MAC algorithm and also some of the MAC value. The next, let us see an example of how they are going to send the information, how they are going to be receiving information. So in the message format, so we are having the key of secret key by using the MAC algorithm, both the message and the MAC message authentication code. Originally we are using the only single key. Here we are using the only single key of K. So by using this, it should be equal or not. They will check how it is going to be equal or not. So by using the key K and MAC algorithm, it contains the original of the MAC purposes. So basically we are going to send the information by using message. After that, the K key, we also use an MAC algorithm for the purpose of the MAC, and the receiver also gets the same of output process. That's why they are usually going to check an equal process or not. So the sender uses some of the known as MAC algorithm. So basically the sender uses some of the public algorithm is known as MAC algorithm. So it basically inputs the message and also the secret key K, and it produces the MAC value. By combining of MAC algorithm and the message and the secret key, it will produce an final of MAC value. Means whatever we are going to convert some of the authentication code in any of the hash formats or numbering format, we are going to be convert as an authentication process, and finally we are going to get some of the hash value. In HMAC and CMAC, we can see the originality of how they are going to be work. In the next video, I will discuss HMAC and CMAC. So similar to the hash, MAC function can also compresses an arbitrary long input to a fixed length output. So in HMAC, there will be a one hash length value. Means by using an MAC algorithm, it will get one of the particular of hash value. So basically it will get the hash value. So it will comes to the HMAC. So that is the major difference between hash and the MAC. That's why they are using the MAC of the purposes by using during the compression process. But during the compression, they are using to the secret key. So between hash and the MAC, that is the major difference. The next one is the sender also forwards the message along with the MAC. So it basically provides the message only of the originality of the authentication. So whenever it is required, the confidentiality is required, the message needs also encryption process, not as decryption process. The first we need to do as an encryption process, then after we need to do the decryption process. So whatever the information will be get as an from the sender and the receiver, it is going to be an encrypt, and this is going to be an decrypt process. That's what we have done in the same process of encryption and decryption process. In this, we are done with the encryption process, and here we have done with the decryption process. So if confidentiality is required, then the message needs encryption. So whatever the information we are getting, that is the message should be need an encrypted format. Should not share the information to any other person or any other related of the third person or the third hacker, or any of the information should be an encrypted format. It should not reveal the information. So on the recipient of the message and the MAC, the receiver feeds the received message and also the shared key. The shared key is nothing but a K. So it contains into the MAC algorithm and recomputes the MAC value. For example of the message, the receiver feeds an original key, that is nothing but an shared key. So whatever we are getting the here shared key of message, that is going to be an recomputes the MAC value. So of the next process, the receiver now checks the equality of freshly computed MAC and also MAC value received from the sender. And it obviously checks the message, whatever they are sending, it also checks from the sender also, whether they are sent the correct information or the not they have received. So if they match, then the receiver accepts the message and assures himself that the message has been sent by the particular sender only. So after the confirming of all these things, the receiver will accept the message. Means whatever the message, the sender which has been sent to the receiver of the original message, the receiver should be accepted of the message. So that the message has been sent by the intended sender. Means the sender, whatever the information is sent, the receiver will be accept. If it is wrong, it won't be an acceptable format. It is correct, that's why only the receiver can accept the message format. If the computed MAC does not match the MAC what is sent by the sender, the receiver cannot determine whether it is the message that has been altered or not. Means any hacked or not, the receiver cannot any determine process of MAC does not match the MAC what is the sended of the value, the receiver cannot determine what they are going to be happen of the third process. The third process is nothing but a hacker. For example, here sender is there, here receiver. The sender is going to be check of the whole messages. For example, here I am giving the hi, how are you? This is the message I am going to be sent to the receiver. So here is the third one, means nothing but a hacker or any other intruded party. Okay, third party. Third party is there, here sender is there and also the receiver is there. So I am sending the message of hi, how are you? This information should be sent to the only the receiver. Here hacker cannot gain the information. So by should not gaining the information, the original message should be equally sent to the receiver. So that what we are saying here, whatever the MAC received from the sender, if it is match, they can accept the receiver. Otherwise, if it is not match, the sender cannot know whether the information is hacked or not. That is the difference between the sender and the receiver and the message or altered. That is the basic of difference. That is the message authentication code. So in today's session, we have discussed with the authentication requirements, authentication functions and what is the MAC functions and how it is going to be work. It is nothing but a message authentication code. In the next session, we will going to discuss about the SHA and HMAC, CMAC and also the digital signature standards algorithm. In the next session, we are going to be discuss this of the topics. Thank you.